Hello students, my name is Ankit Kumar. I welcome you all in the Eureka Institute. Today's first topic we are going to start is units, errors and measurement, which is very basic topic of physics 1. So let's start. We know units and measurement, we need to define it with the help of certain physical quantities. And physical quantities are the quantities which can be measured by an instrument and by means of which we can describe the laws of physics. So there are several fundamental or basic quantities. There are certain derived quantities and there are certain supplementary quantities that we will discuss one by one. So let's start with the fundamental or basic quantities. These are called basic quantities because these cannot be derived or these are not derived from any other forms. These are original forms of units. For example, we have length, we have mass, we have time, we have temperature, we have luminous intensity, and we have amount of substance that is called moles. So we have 7 fundamental units. Next is the derived unit, and derived units are which are derived from the fundamental or basic quantities. From the name suggests, derived means it has been extracted from the fundamental quantities. An example for this, let's say force. Force is equal to mass into acceleration. So it is function of mass and acceleration. So we have a fundamental unit for mass which is the m, and acceleration can be expressed in terms of velocity per unit time. Again, velocity is not a basic quantity. Velocity is again a function of distance per unit time. So it can be written as that mass into distance, the distance per unit time, and it will become per unit time square. So we have fundamental quantities for mass, distance and time, and that can be expressed as m l t square, or in general form we can write that m l t minus 2. So the force have a derived unit which is m l t minus 2 dependent on the fundamental or basic quantities. For example, we have a momentum that is expressed as product of mass into velocity, and we can say that again this velocity is the ratio of distance upon time, and all these are fundamental quantities. So we can take this formula as mlt minus 1. So these quantities, force, momentum, similarly we can have torque, pressure, which are or which can be derived from the fundamental quantities are called derived quantities. Next is the supplementary quantities. From the 7 basic fundamental quantities, we have 2 more different quantities, and these are the plane angle. Let's say plane angle is the angle subtended by two lines. Let's say this angle is theta. So angle between two lines is called plane angle. And suppose we have a solid object like a cone for ice cream. So this is a cone, and this angle theta, we will say that this is a solid angle, right? So solid angle is subtended by a 3D geometry, and if the angle is taken between the two lines, then it is called plane angle. So these are also called as the supplementary quantities. Then next, in the topic of fundamental quantities, we have a principle of homogeneity. And homogeneity principle says that the dimension of all the terms in a physical expression should be same. That means the left hand side and right hand side, the dimensions are equal. For example, we have a relation that x equal to ut plus half at square. This is a very simple relation that we know for a motion in a straight line. So the distance s has a fundamental quantity like L. Then these all the quantities which are added together, these must have same units or same fundamental quantities. For example, u is the velocity or initial velocity. We can write that velocity is equal to distance per unit time and multiplied by time, and plus half. This number is a dimensionless number. And then acceleration. Acceleration is velocity per unit time into time square. Again, this velocity can be replaced with respect to distance per unit time. So we can write that L into T upon T plus half into L upon T square into T square. So you can see that this left hand side is equal to summation of right hand side unit quantities. So the unit quantities on the left hand side are equal to the unit quantities on the right hand side. Means left hand side and right hand side both have the same fundamental units, otherwise they cannot be added together and subtracted from each other. In addition to the fundamental quantities or derived quantities, we have several other quantities which are called angular quantities. And in angle, we can say that if this is an angle between two planes or two lines, let's say theta, then the distance traveled by this is, let's say, x. Angular quantities suggest that if I write angular velocity, angular velocity is the ratio of change in angle per unit time. And what is the angle that is changing? It is theta, changing per unit time, t. So this is called angular velocity, and we introduce a symbol omega for this. So omega equal to theta upon t. Now we have discussed theta before. Now let's take it again. Theta is equal to arc upon length. Let's say this is the length L. This arc is also a length. So this is L by L and its unit becomes constant. So we can write that it has no mass, no length and no time. So this is the fundamental or quantity for theta. So we can say that it is a dimensionless number. So if theta is dimensionless, then angular velocity we can write that 1 upon and time t. So this is the formula for or dimension for the angular velocity. So we can write that it is m0, l0 and t minus 1. So we can find the dependency on time on the angular velocity. Similarly, we can write the angular acceleration term. In angular acceleration says it is the ratio of the change in angular velocity per unit time. So means it is the d omega by dt by formula, and omega has a dimension of m0, l0, t minus 1, and this time has a dimension of t. So after simplifying this, we can write that m0, l0 and t minus 2, it is the dimension for angular acceleration. Similarly, if you want to calculate the relation for torque, so we know that the torque is equal to force into the perpendicular distance, and that is called as the radius. So we can say that this is the arm length at which that force is applied and due to which that rotation motion is possible. So this force, we have derived this dimension formula that it is mlt minus 2 and arm length is L because it is again a distance. So we can write that it is m L square and t minus 2. So this is the dimension for torque. In continuation with the homogeneity principle, let's take one more example. And I'm writing the van der Waals equation. It is P minus A upon V square in bracket and V minus B equal to nRT. This is the van der Waals equation where P supposed to be a pressure and your V is the volume and T is the temperature, where A and B are the constants and you have to find the dimensions for A and B. So how you can calculate? You know, from the principle of homogeneity, all the term in the bracket should have the same dimensional formula. So for example, let's take the first term, which is the P minus A upon V square. When P is the pressure, so from the principle of homogeneity, we can say that a quantity which has a same unit equal to pressure can be subtracted from this quantity. So that means that A upon V square should have a unit identical to the pressure. So we can write that A upon V square like this equal to m L minus 1 and T minus 2. This is the dimension for pressure we have derived earlier, and you can derive it again also, that the pressure is equal to force per unit area. Force has dimension of m L T minus 2 and upon area. Area has dimension of L square. From this you can write that it is m L minus 1 and T minus 2. So this is for pressure. So this A upon V square should also have the dimension equal to this pressure, and by this we know that this V is the volume Volume is the 3 times multiplication of a side. So it has a dimension of L cube. So I can write that dimension for A that we have to calculate upon L cube and square equal to ml minus 1 and t minus 2. So from here you can get that this is m l power 5 and t minus 2. So this is the dimension for A that you got. Similarly, the second term under consideration is v minus b. So this b must have the units or dimensions equal to the volume. So simply you can write that dimensions for b is equal to L cube, or you can write that m0 L cube and t0. So next topic is error and measurement. Error is the difference between the real value, which is also called a true value, and the measured value. So there are several types of errors that have been occurred during the measurement from the instruments. In broad classification, this error can be classified in two types on the basis of cause of error and the magnitude of error. On the cause of error, this again can be divided into two types. First is the systematic error and the second one is random error. Systematic error is the error which is created by the system itself. It can be eliminated, and we have to understand that these are the fixed value errors. So first example is the instrumental error. The error occurred by the instrument is called instrumental error. That may be because of its vibration, and that may be because of the any inefficiency in the instrument. During observations, there may be several ignorance of the facts, and due to which the next type of error is occurred, which is called imperfect technique error. These can be removed by following several precautions. For example, in making connections with electrical circuits, we have to take that all the connections should be fully tight. There should not be any loosening. In a simple pendulum experiment, we measure the length of rod at which the ball is connected. We measure the length of this rod on the table, and then we put it on the one end is hinged, and then put a ball on the other side. After that clanging, we measured this length again, and then we found that this length is slightly increased, and there is a certain difference from the previous case, and that may be due to the force exerted by this mass due to gravity. So this length may be extended. So this may be a wrong technique to measure the length of this rod. Sometimes we measure the length of this thread only, and we forget that this ball has a diameter, and we have to actually measure this length from the top to the center of that ball, but we measure only the length of this rod. So due to this, we can also say that this is an imperfect technique, and due to which the error is enhanced in the measurement. Then third type of error is a personal error. This personal error is occurred due to the person who is conducting that experiment. For example, if he has different angles to read that glass covered readings, then he find due to the projection of that glass that different values, and this type of error is also called a parallax error. Next type of error is error due to external cause, and this may be because of the temperature, pressure, air velocity and other factors like dust and dirt in the environment. So these are the environmental factor. So if you want to remove this error, you have to take care and you have to perform your experiment in a very closed room. And the last one is the least count error. It is also a systematic error. It is because of the instrument and because of the least count, and certain because every instrument has a least count. And let's say we have an instrument like this, and it has this least count of 1 mm, right? So this is, let's say, 1 2 3 4 5 6 7 8, and we measure from one end, it is value like this, and we have a value like this. So both these values are in between this 6 and 7, and your instrument has a least count of 1 mm. So these both values, let's say A and B, both these values may be assumed equivalent to 6, but these are not exactly 6 because this error is encountered due to the least count of the instrument. If your instrument has further minimum least count or 0.1 mm say, then you can easily measure this length. Now next is the random errors. And these random errors are the irregular errors. And these errors, we don't have the sources. We cannot find the sources due to which this error is occurring. For examples, let we are doing a simple pendulum experiment and we want to calculate the gravitational acceleration value at that particular location. And we know the formula for time of simple pendulum is equal to 2 pi under root L upon G. So in this, the time taken for that oscillation to diminish, that can be calculated from the stopwatch. 2 pi is a constant length of this rod on which the ball is pinned. We can measure that we have done earlier, and from this we can calculate the value of G at that location. So during several experiments and due to all these systematic errors, we found that there are different values of G in different experiments. For example, let's say it is value in one experiment we found 9.85, and in next experiment we found it is 9.78, and in next experiment we found it is approximate 9.79. These all are correct values, but the variation is unknown. You can't find the reason for these errors. So that is why these are called random errors. Next, type on the basis of magnitude of error, and if we want to calculate how much is that error in a particular experiment, then we have three methods, and this is called absolute error, mean absolute error, and relative errors. We will discuss these errors one by one. Let's take the absolute error. Absolute error of an observation can be calculated by this delta A equal to true value for A minus the measured value of A. Now, how can we calculate this true value? This by conducting several experiments and then taking average of them, we can get the true value. And then from the experiment, what we are actually conducting and what we want to measure is the measured value, and the difference between those two will give you the absolute error. For example, I have measured the length of a rod as equal to A1. This has certain numerical value. Then I have measured again and I got A2. Then I measured again by several different technique and I get A3. Then again I measured and I measured n times. So let's say I have n values of that rod which is measured by several different techniques, and then I will add all these terms and then find their mean, and this will give the true value. So this becomes the true value for that particular rod, and then I'm going to do an experiment and I measured and I found that this value is A. Then I will get this absolute error by the difference from the true value which has been already taken previous experiments, and then I subtracted from the measured value that I measured on that moment. So that difference will be called as absolute error. Next type of error is the mean absolute error. The error or absolute error calculated in previous case, let's say delta A. I have conducted one experiment. I measured one delta A, means one absolute error. Let's say it is delta A1. Then again I conducted an experiment, and from the difference taken from the true value, I have taken the absolute value or absolute error as delta A2. Then again I did it third time and I found absolute error as delta A3, and I did this experiment as n number of times. If I add all these absolute errors together and find their means, and that mean is the absolute value, means the positive value, I have taken all these positive values and found their mean, then it will give the mean absolute error, and I can write like delta A mean is equal to sum of the absolute errors upon number of observations taken. We have taken this mod because we have to deal with the magnitude only. That's why we have taken this mod. We don't have to consider its sign. Now third is the relative errors. And let us understand this relative error with the help of some example. Let us take we have a distance measured which is equal to 100 plus minus 2 kilometer in one experiment, and then in next experiment we have measured that distance is 1000 plus minus 5 kilometer. So how we will find out that which experiment was accurate and which has more error? So for this, we do certain calculations. We can say in experiment number 1, per 100 kilometers, the error is 2 kilometer. And in experiment number 2, if we want to calculate per 100 kilometer, the error is equal to 0.5 kilometer. You can find out by using this same correlation. That means the experiment conducted in second time is the comparatively best. It is relatively best. So we say that this is relative error. If we rewrite this equation like 2 upon 100 or 5 upon 1000, we made fraction of this error. This is called fractional error, right? So if we have taken the fraction, it will form fractional error. If we rewrite again and write like this, that like 2 upon 100 into 100, or we can write that 5 upon 1000 into 100. So we have mentioned it in the form of percentage. So this can be called as, or we can write that this is 2% and this is 0.5%. So that means we will say that this is the percentage error. In conclusion, we can say that relative error is equal to fractional error or error upon original observation. So you can write that fractional error is equal to this error upon original observation. So original observation was, see, 100 was original observation, error was 2 in experiment number 1, and original observation was 1000 and 5 was the error. So we have taken this ratio, it becomes fractional error, and if we multiply it by 100, then it will become percentage error. So let us have an example. The refractive index of water found as 1.29, 1.33, 1.34, 35, 32, and like this. So we have these experiments 1, 2, 3, 4, 5, 6, 7, and 8. We have these 8 experimental observations, and we have to calculate the mean value, mean absolute error, relative error, and percentage error. So let's do one by one. First one is the mean value, and mean value is calculated by adding all these experimental values like 1.129, 1.33, and 1.34, and so on. Let's 1.33 and divided by 8. We have summed up all these value and divided by 8. We get certain value, that 1.32, and this becomes the true value, right? It becomes the true value or the mean value of the observation. For second question, we can find that mean absolute error, like this becomes the true value. And if I want to calculate the delta A1, this is the A true value minus A measured value. Now you can understand how it is done. So A true value is 1.32 and minus A measured value, because it is the for first mean value. So I will take this value like 1.29, and this value will come out as 0.03. Now if I want to calculate delta A2, then again it is 1.32 and minus this second value, and this second value is 1.33. This is 1.33 and this will become minus of 0.01. Similarly, the third error, these all are the absolute error for particular experiments. So I am calculating now the absolute errors, and then similarly the A or delta A3 will be equal to 1.32 minus 1.34, and this is equal to minus of 0.02. By this way we calculate the delta A8, which is the minus 0.01, and then I am asked to calculate the mean absolute error. And how we calculate it? That absolute mean is equal to the mod of absolute 1 plus mod of absolute 2 and plus so on mod of absolute n, right, and divided by 8. So we get all the positive values of this error, and then we add it by 8 and we get that 0.02. This is the mean absolute error for this experiment. If I want to write the relative error, this relative error will be equal to this 0.02, and observed value is 1.32, and this ratio gives you the relative error. Next, if I want to calculate the percentage error, then percentage error can be written as 0.02 upon 1.32 and multiply it by 100. This will give me the percentage error for this problem. Now we have a case that let the length of room is equal to 10 meters and plus minus 0.1 percentage. It is certain measurement. Let breadth is equal to 10 meters and plus minus 0.1 percentage. Now the area of this room will be equal to length into breadth. If area is equal to length into breadth, then question comes, what will happen to the error? So we say that this is called the propagation of error. The one observation that come into our mind is that error may be multiplied. So this type of complex thing where the addition or subtraction, multiplication and division of these two types of dimensions have been done, what happens to that error? That error is propagated, and that is called propagation of errors. And this propagation of error is done by four means: addition, subtraction, multiplication and division. Let's start with the addition and subtraction operations for the errors. So in this, we simply add the measured quantities or simply subtract the measured quantities and then add their errors. What does that mean? For example, we have an experiment and we have measured a distance like 110 kilometers with plus minus 5 kilometers of variation. And second experiment we have, let's say it is 120 kilometer and plus minus 6 kilometer. So these are the two experiments and with errors. So we can write this error like this limit 110 plus minus 5 kilometer means it can be from 105 to 115, and this can be written as the variation in this experiment number 2 is from 114 to 126. If I add these two, what we get is 219 to 241. So the variation will be from 219 to 241, and we can simply write in terms of errors like these two are simply added, means it is like 230 and plus minus 11 kilometers. So in this way you can simply find out that this expansion is also valid. That 230 minus 11 equal to 219 and 230 plus 11 is equal to 241. Means the conclusion is errors are always added up, whether it is subtraction or addition. So let's take an example. Let us take the sides of a rectangle are 10.5 plus minus 0.2 and 5.2 plus minus 0.1 centimeter. So let's say this is L and this is breadth of that rectangle. Now we have to calculate the perimeter with error limits. So what is perimeter? We know perimeter is equal to 2 times of L plus breadth. Now we can say from the previous concept we can write that the mean value is simply added is equal to 2 times of L is 10.5 and plus 5.2. This is the approximate equal to 31.4. Now what will happen to this error? This is 0.2 in this case and this is 0.1 in this case. So the error, for error if we want to write or calculate the perimeter, this is equal to 2 times of delta L and plus delta V. And simply we can write that this is 2 times of 0.2 and plus 0.1, which is 0.3, and multiplied by 2, it is equal to 0.6. So the final perimeter we can write it is equal to 31.4 plus minus 0.6 is the final answer. Let's take one more example, that the initial and final temperature of water is 40.6 plus minus 0.2 degrees Celsius and 78.3 plus minus 0.3 degrees Celsius. So calculate the rise in temperature. Rise in temperature means the delta T, which is the final temperature minus initial temperature. This is the rise. So final temperature is 78.3 and minus final initial temperature is 40.6. So this difference is equal to 37.7. What will be this error? So for error we can write that error is again the difference. No, it will be addition, because rule says the errors will always be added together. And the error is 0.2 and plus 0.3, which is equal to 0.5. So final answer can be written as 37.7 plus minus 0.5 degrees Celsius for the rise in temperature. Clear? So addition and subtraction, that is clear up to this example. Let's take the propagation of error with multiplication and division. In multiplication or division, the relative errors are added. This gives the relative error of product or the gradient. What does that mean? That means we have a value a plus delta a or a plus minus delta a. This is one dimension. And let's say we have other dimension, that b plus minus delta b. Then if we want to calculate the product, what will be the product? This is a cross b. This is for mean value, means the actual value or actual observation. What will happen with this error? Error will like delta a upon a and plus delta b upon b. This is for error. Means error will not multiply. They will be added, but added in relative terms. So this is the fraction, and this fraction is added together for that relative error. Let's take an example. Length and breadth of the rectangle are 5.7 plus minus 0.1 centimeter and 3.4 plus minus 0.2 centimeters. And we have to calculate the area of this rectangle. So area of this rectangle is equal to length into breadth. So by this we can calculate this real values. These are the real values and these are the errors, right? So we have to multiply the real values and add the errors in relative form. So let's multiply the real value. So this is 5.7 into 3.4 and the result will be this 19.8 centimeter square. Now let's take the error part. This error will be added in fractions. So 0.1 upon 5.7 and plus 0.2 upon 3.4. Because this delta A error in area upon area, this is the fraction term and this is equal to delta A upon A and plus delta B upon B. So this is A length, right? And this is B length. And this ratio, what is this? This is the delta A and this is the delta B, right? So we have taken this, and if we do the addition of this, we can simply take the LCM, and this LCM is 5.7 into 3.4 and this can be written as 0.34 and plus 1.14. After taking the LCM of these two, we get this value, and this delta A upon A is equal to 0.34 plus 1.14 upon 5.7 into 3.4. And what is this A? This A is already calculated. See, this area, which is equal to 5.7 into 3.4. So I can write that this is delta A upon 5.7 into 3.4 and this term is cancelled. So delta A is equal to 0.34 plus 1.14 and this is equal to 1.48 centimeter square. So final answer will be like 19.8 plus minus 1.48 centimeter square. This will be my final answer. Let's do one more problem. Let a body travels uniform distance of 13.8 plus minus 0.2 meters and it takes time of 4 plus minus 0.3 seconds. So we have to calculate the velocity. From the physics concept, we know the velocity is equal to distance upon time. So distance upon time means 13.8 plus minus 0.2 upon time 4.0 plus minus 0.3. So this should be the final result. So how do we calculate? We divide this real values and then fractional values of the error are added together. This is the rule that we have studied few minutes before. Now let's do that. So velocity is equal to L upon T. This is the real velocity or measured velocity. Now this is 13.8 upon 4.0 and this is approximately equal to 3.45. Right? What is happened with this error? Now take this error part as delta V upon V, which is equal to delta A upon A and plus delta B upon B. No matter it is division or multiplication, these errors will be always added together in fraction form in case of multiplication and division. That you have to take care of it. So we can write that this is like 0.2 upon this 13.8 and plus 0.3 upon 4.0. Again, after taking this LCM and all, we can write like this is 13.8 into 4.0 and we can multiply it by like 0.8 and plus this is 4.14. This is equal to delta V upon V. See this V, we have calculated this. This value is 3.45. So from here you can calculate this delta V and this comes out as approximately 0.31. You can calculate it. You can do the calculation and you will find out that this value comes out approximately 0.31. So final velocity you can write like 3.45 and plus minus 0.31 meter per second, and this is in brackets. So this is the final answer. Let us take another example that when we have an expression of certain power n, let x is equal to a ki power n, or if we found that there is certain error in this value a or measured value a, then what will happen with the value of x? There might be again several errors. And how do we calculate it? Let's do this. This x is equal to a into a into a into n times, right? We can write this. Now if a has certain error, if this term has certain error of plus minus 0.1, let's say, then how do we write it? That delta x upon x, this is the method we have taken, that this is a multiplication form, and what we have to do with the error, the real value is calculated with the same multiplication of this value and the error will be calculated with the addition of that error. Fraction addition of that error has to be taken. So this means this is equal to delta a upon a and plus delta a upon a and plus delta a upon a and plus up to n times. So this you have to add together n times, and this is simply can be written as n times delta a upon a. This is equal to the relative error in which the expression is some power raised to n, right? So this is the error, or we can say this is the fractional error. And if we want to calculate the percentage error, then we can write that this delta x upon x into 100, it is equal to n times delta a upon a into 100, your percentage error. Fine. So let's do the example. Let we have a sphere and its radius is equal to let's say it is 2.5 and plus minus 0.2 centimeter, right? So this is the radius for sphere. In this case, if you are asked to calculate the volume of this sphere, then you know the volume of a sphere is 4 by 3 and pi r cube. This is the volume. In volume formula, you can find that this 4 by 3 into pi is a constant term. This has no error. This is r cube. Means you can simply write this 2.5 cube. This will give you the real value. And what will be with errors? This is 0.2 is the error for first r, and here it is cube. So you can simply using this formula, you can write that this is 3 times multiplied by 0.2 upon 2.5. This is the error part. And this is the absolute part or real part. Got it? So this is approximate the 0.24, or if you multiply it with 100, then it will be like 24%. So this is the percentage error in volume. 24% will be the error in the volume. Similarly, in this example, if you want to calculate the surface area of that sphere, then I'm writing this value again, that this is 2.5 plus minus 0.2 times centimeter. And if you are asked to calculate the surface area, and you know the surface area is 4 pi r square. Now again, 4 pi is a constant term, it has no errors, and this r is square. So percentage error in area can be written as this 2 times of r, or delta r upon r. So this can be written as 2 into 0.2 upon 2.5 and multiplied by 100, right? So here you also have to multiply with 100. So that's why it comes this value. So you can get the percentage error in area. Let us take another example, that in an example we have a relation like x equal to a square and b cube upon c and under root d. This is a certain complicated expression for x, and the error in a is equal to 2%, error in b is equal to 1%, or I should write like this is the error, and error in c is equal to 3%, and error in d is equal to 4%. Then what will be the percentage error in x that you have to calculate? How you calculate it? See, this, there is multiplication, there is division. Both are at the same time. What you understand is the percentage error or relative error are added together in fraction form. So the percentage error, you can simply write this error is equal, or in x, this percentage error in x is equal to the 2 times, let's see, a is power 2, so 2 times 2%, and plus b has 3 power, so 3 times 1%, and plus c has 1%. C has one value, so 1 into 3%, and plus d has power. See, very careful about this. D has power of 1 upon 2 because it is under root by d. So under root d means 1 by 2 into 4%. So after solving this, you will get the 12% error in the value of x if a, b, c, d has certain mean error of 2, 1, 3 and 4% respectively. So this is all about units, dimension and measurement. Hope you understood the clear concept of this measurement. So thank you very much.